Let's look at this particular example. Well, using this example to compare and contrast the two different systems. So the CTAC produced three different kind of products, and they were Model 1, Model 2, Model 3, and the following information is on the company record. Model 1 got 10,000 units, Model 2, you produce 20,000 units, and Model 3, you produce 4,000 units. And we only took one production run to complete the entire Model 1, 10,000 units. So we just run it through once, and then 10,000 units Model 1 is done. However, when we produce Model 2, it takes us 4 runs. So you produce 5,000 units, and then you stop. And then you start the process again, produce another 5,000, then you stop. So you did that 4 times. And for Model 3, although we only produce 4,000 units, but it's a little bit complicated. Maybe the process, the production procedure are pretty complicated. So it takes us 10 runs, or they maybe just come with small orders. So we only produce 400 units per run. So overall, we did 10 production runs in order to produce 4,000 units, all right? So you clearly can see there here, although the Model 3, you only produce 4,000 units, but you're engaging in a lot more activities in terms of production runs. You did 10 times versus Model 1, you did more than twice as many, like 2.5 times many units you produced, but you only did once. So you only engage in one production activity versus Model 3, you engage in 10 different activities. So if the production run, each run costs us a certain amount of money, obviously, it's going to cost us more to run the production to Model 3 versus Model 1, right? Same thing. Model 2, 4 runs, Model 3, 10 runs. You got the point, you get my points, right? So, but right now, if we just ignore those, the difference in terms of production runs, we just consider they're all homogeneous. We produce 1 unit Model 1 is 1 unit Model 3. They're the same in terms of complexity of production. That's the traditional system. So let's see how traditional system allocate. So the traditional system trying to allocate the cost, overhead cost, cross-board using the direct labor hours. All right, so this is a traditional system. You got direct material, direct labor, and you allocate overhead. How did we get those overhead? Well, let's see. So basically, traditional system is, okay, you produce 10,000 units, then each unit costs us 3 hours, all right? So 3 hours times 10,000, our total direct labor hours is 30,000 hours, all right? And then, so 30,000 hours for Model 1, and 80,000 hours for Model 2, and 8,000 hours for Model 3. So total labor hours we use to produce Model 1 and Model 2 and Model 3 is 118,000 hours. And then since our total overhead cost is $3,894,000, $3,894,000, and divided by 118,000 hours. So in average, we have $33 per labor hour, all right? Therefore, 30, so since it takes us 3 hours to produce 1 unit of Model 1, so each hour costs us $33. Therefore, 1 unit of Model 1 costs us $99. Same reason, 1 unit Model 2 costs us $132 in terms of overhead cost, and the Model 3 costs us $66, all right? So hopefully that calculation is pretty straightforward. So in this case, then our total cost per unit for Model 1 is 50 direct material, 60 direct labor, plus $99 we allocated overhead cost based on the direct labor hours. So the total cost is 209. Model 2 is 302, and Model 3 is 126. If the company trying to price that product by adding 25% on top of the cost, which that's what that means, okay? So your cost will be target selling price will be this one, 261.25 for Model 1, 377.50 for Model 2, and 157.5 for Model 3. So this is our traditional system. For the activity-based costing, we have different way to look at this. So again, the total overhead cost $3,894,000, $3,894,000. Remember, the stage one is ask us to allocate those costs into different cost pools. All right, step one. So we'll identify the activity cost pool. So here we talk about the activity hierarchy. There's a unit-based or volume-based. Sometimes they use volume-based, or sometimes they use unit level or volume level. They're the same thing, okay? And then we have batch. So in this case, we said machineries. So the more unit you produce, the more machine you have to run. All right, so that's one activity pool is already been identified. And then the second is batch related, batch level, which is activity performed on each batch produced, not on each unit produced, but on each batch, just like you bake cookies. In your oven, you put each batch of cookies, maybe 200, maybe 100, maybe 20. So each batch, all right, you don't bake one cookie at a time. You bake a batch of cookies. You bake, you do bread, you do a batch, all right? Just like you wash clothes, you do a batch of clothes, dump into the washing machine. You don't wash one shirt at a time. So that's batch level. In this case, for example, the setup cost, each time before you do production runs, you have to do some setups. You have to be prepared to run the production, so that's setup cost. And then there's other type receivings or inspections. So when the material being shipped to your floor, shop floor, or your manufacturing floor, you inspect them, you receive them. Whether it's one unit arrived or 100 units arrived in your warehouse, you inspect them, you do one inspections. And then the material handling, you move one forklift of merchandise, one truck of merchandise or material. So whether that truck has 200 units on it or 300, it's one truck. So material handling is batch related. So it's quality assurance means quality control. And then packaging and shipping, same thing. If you ship one product out versus you ship 3 product out versus you ship 10 units out, you put in one package. So you do one package. Again, those are batch related. And then there is a product sustaining, like engineering, like designing, like retooling of the product. So Model 1, Model 2, Model 3. So you got 3 different type of products. So the engineering cost that only relates to how many type of product you have. You don't do design for each unit product, right? You do one design for one type of product. So in here, that's product sustaining. Then facility level is whatever the security guards for the host facility, so on and so forth. So that's facility level, all right? So that's the ABCs, that's the first stage. And the second stage, so let's take the look, let's do this one at a time, one cost pool at a time, okay? The second step, if you kind of go back to the earlier slides. So the second step is identify cost drivers associated with each activity pools and then determine the rate. So we'll identify the cost driver for the machine is we allocate stage one, we understand we allocate about $1,212,600 to this machine pool. Normally in a problem or in exam or in homework, this allocation is given to you. So you were told how much cost belongs to machinery pool. Sometimes it's not, but most of the time it is. When it is not, then you need to calculate. There should be a way to figure out how much cost goes into each type of cost pools. But right now you're given. So the cost pool for machinery is $43,600. And the driver is machine hour. So we have step 2 and 3, we identify driver, and then we calculate the driver rate. So we know that there are 43,000 hours, machine hours overall. In order to perform those 43,000 machine hours, it costs us $1,212,600. So we can calculate average, how much does it cost us per machine hour? We were able to calculate $28.20 per machine hour. So for Model 1 per unit, it takes us 1 machine hour. Therefore, per unit Model 1, our cost allocate from the machinery pool is $28.20. And then for Model 2, it costs us 1.25 machine hours per unit of Model 2. So using 1.25 hour times $28.20 per hour, you allocated $35.25 of machinery cost to each unit Model 2. Same thing, you allocate $56.40 of machinery cost to Model 3. Again, sometimes those numbers right here are given to you. Sometimes, like this number is just 43,000, sorry. 43,000 was given to you right here. But you can calculate. Remember earlier we said, how can you calculate this? Well, a lot of time the problem not giving this 43 gave directly to you, but you can calculate based on the information given to you. So let's see, we had earlier, I show you when we did the traditional ones, you understand that we have, so we made 10,000 unit Model 1 and 20,000 Model 2 and 4,000 Model 3. And then each unit of Model 1 costs 1 hour machine hour, and Model 2 costs 1.5 hour, and Model 3 costs you 2 hours of machine hours. So with those information, then you can see that then we can calculate this easily, all right? How do we calculate? So here is 10,000. So Model 1, Model 2, Model 3. So 10,000 units right here, we know that. This is 20,000 units, we know that. And this is 4,000 units, okay? And each of them costs 1 machine hour. This is 1.5 machine hour. And then this is 2 machine hours. So how many machine hours for Model 1? 10,000 hours, right? How many machine hours we have this one? 20 times 2.5, that's like 20,000, and then 25,000, I think. I could be wrong. Yeah, 25,000. 25,000 machine hours, all right? And then here is 8,000 machine hours. So if you add this 3 together, you have the sigma is 43,000 hours. That's how we got that 43,000 hours. If they're not given, then you can calculate, all right? So we got here, we now know the machine hours allocated to the overhead cost, that the machinery cost that allocated to Model 1 is $28 per hour, $28.20 per hour, and allocated Model 2 $35.25 per hour, and Model 3 is $56.40 per hour for machinery costs, all right? Let's look at the next one, the setup cost pool. Let me erase this first. Right in here. Okay, for the setup, because it's a batch related activity and we were giving $3,000 was allocated to there because you can hear it says $20 per setup hours and 10 hours per setup. So that's like $200. And then 15 production runs. So total of $3,000. All right. So $3,000 was allocated to, during the stage one, was allocated to this pool. All right. And then the second step is going to be $3,000, 15 runs. So it's $200 per run. And then for the Model 1, we have only one runs. So $200 per run divided by 10,000 units. So we were able to allocate 2 cents per unit for Model 1 of setup cost. All right. And for Model 2, we had, again, it's $200 per run, but we, each run, we only run 5,000 units. You can see in the previously in the data we had, each run, we produce 5,000 units. And since each run costs us $200 per run, and in that run for Model 2, we were able to produce 5,000 units. Therefore, per unit of Model 2, in terms of machine setup cost, is $200 per run divided by 5,000 units, which is 4 cents per unit. Same logic for Model 3. Each run, we can only produce 4,000 units, so $200 per run, and then we were able to produce 400 units of Model 3. Therefore, 200 divided by 400, that's 50 cents per unit for Model 3 in terms of setting up costs. All right. So let's move on to the next engineering costs. We were given 700,000 units was allocated on the stage one to the engineering cost pool. And then since for this 7,000 units, we have 3 models, Model 1, Model 2, Model 3, but we can simply divide it by 3 because each product are different. And Model 1 is much simpler, and Model 3 is complicated, Model 2 also complicated. So we ask engineering department, ask them, well, how much activities that, or out of the total activities you are engaging in engineering, approximately how many activities proportionally or time you spend on Model 1 and what time you spend on Model 2 and how many time proportionally spent on Model 3. And so they gave us, okay, we spend about 25% of time in Model 1, 45% of time on Model 2, and 30% of time in Model 3. Okay, so this is an example that sometimes in the previous one, we were able to, based on how many runs, we give you quantities, but other times we use proportions. All right, in this case, engineering cost is proportion. So 25%, it goes to Model 1 and 45 Model 2, 30% to Model 3. So we use those proportion times the total cost of $700,000. That will be the cost allocated for Model 1. So this is the cost allocated to Model 1. This is the cost allocated to Model 2, and this is the cost to Model 3. And so we take that cost divided by the units of Model 1 to get this much, the unit cost. Same thing, this is unit cost, this is unit cost, okay? In terms of engineering cost, allocated to Model 1, Model 2, Model 3 at the per unit base, all right? So let's erase those. And then we got facility. We decided the model for the cost for the facility cost pool is 500 and 7,400. And then we decided we're going to just simply allocate that by direct labor hours. And we know that we had 118,000 direct labor hours. Therefore, per direct labor hour is $4.30 of facility cost. Since it takes about 3 hours per unit for Model 1. So 3 times 4.3 gave us 1290. 4 labor hours per unit of Model 2, and 4 labor hour times $4.30. We got 1720, and 2 times 430, and we got 860. All right. So that way we're able to find out how much facility cost per labor hour we're going to use to allocate. In this case, $4.30. And with the same reason, but this one is more like the engineering will do proportions. So for receiving, we have total cost pool of $200,000. Out of 200,000, we think 6% goes to Model 1, 24% goes to Model 2, and 70% goes to Model 3. Same with material handling, same with quality assurance, same with the packaging and shipping. They just come with different proportions. So with those calculations, we're able to come up. So for other overhead costs, for Model 1, you have $1.20 per unit Model 1 for receiving cost, and $4.20 for material handling, and $8.42 for quality assurance, and $1 for packaging. So total for this other overhead cost is $14.82 for Model 1 per unit of Model 1. Okay, so same thing, you can calculate this, the sum of Model 2, sum of Model 3, so on and so forth. And then ultimately, this is the number. So you will have, again, direct material cost 50 and direct labor 60, and we're able to allocate about $28.20 of machinery cost to Model 1 per unit base, 2 cents setup cost to Model 1 per unit base, $17.50 to engineering, and then $12.90 as a facility cost, and $14.82 per unit. So overall, per unit costs for Model 1 right now stands at $183.44, $261 for Model 2, and $390.85 for Model 3. All right. So altogether, you can see there the traditional costing is totally a little different from the ABC costing. So for traditional costing, you got this for Model 1, 2, and 3. But for the ABC costing, this will be Model 1, 2, and 3. If we do 125% of the costs to price our product, this will be the price if we do traditional, and this will be the price if we do ABC. And clearly, you can see it depends on which costing system we're using. Our price is going to be entirely different. All right. On the ABC costing, the selling price for Mode 1 and Mode 2 has decreased, but the selling price for Mode 3 has increased significantly. Let me erase this right here. So the cost per unit under the ABC costing is deducted from the traditional cost unit. You can see there is cost distortions, all right? This is cost distortion per unit, all right? So that's $25.56 for Mode 1, $40.19 for Mode 2, and negative $264.85 for Mode 3. And this is a cost distortion. They are different. The traditional costing are clearly under cost Mode 3 than the ABC. And if we believe the ABC system is a more accurate one, is more closer to the truth, then traditional costing obviously under cost the Mode 3. All right. This problem with cost distortion is more evident when the cost distortion per unit is multiplied by number. You can see there, then total cost distortion for mode 3 is more than $1 million. All right. The essence of this problem is that traditional volume-based costing system was over-costing the high volume product, which is for mode 1, you got 10,000 units. For mode 3, you only got 4,000 units. So they put more cost to mode 1 than the mode 3, because mode 3 only got 4,000 units. Again, is over-costing the high volume product and under-costing the complex and relatively low volume product, but does more, because it's complex, it involves more activities. And when the more, again, under the ABC, we understand the more activities you engage into, the more cost is going to be. So the high volume product basically subsidizes the low volume product. The activity-based costing reveal these problems and allow us to more accurately assign overhead costs to these 3 different type of product. When the costs are understated, so is the selling price, right? So you're selling mode 3 a lot lower price than what you should have, which artificially appears that you are making profit, but actually you are not. And you overpriced your mode 1. If your competitor does ABC and you do traditional costing, let's say your competitor priced mode 1 at 229, and you price it using traditional system, you price at 261 here, then obviously your customer is not going to buy from you. They're going to go buy from your competitor, which only priced at mode 1 at 229. On the other hand, for mode 3, your price is only at 157.50, and when you should have priced at $488. Now, nobody buys mode 1 from you. They all buy mode 3 because you price a lot lower, but you actually lose money because in the end, you end up selling a product that's very complicated. It takes a lot more people, a lot more activities to produce, because you engage in so many production runs and this and that. So it costs you a lot to produce mode 3, but you're selling at a lower price. So you're going to lose money, you're going to lose, and you're going to eventually go bankrupt. All right. So that's the key. So hopefully this example shows you the compare and contrast between the 2 different systems. All right.